to take you to the company of Aselsan that we are here, that they allow us here to make this workshop here. So on the first workshop is on disruptive innovations. And before I introduce our panel here, which we have a little introduction on the topic, disruptive innovation, we are Institute of Structured Change, and obviously innovations are crucial to make structured change and to define transformation habits. We're here on the COP29 and based on the IPCC reports. And one of the points we discussed since a couple of years is why in the IPCC reports, but more generally, why essentially in transformation paths, disruptive innovations are not part of it. So we only believe on incremental innovation. We don't believe on our own transformation path on disruptive innovation, where we really change things on this point. On the energy transition, we know a couple of names like fusion. Nobody believes on fusion, even though this is a technology option. We have different other options. We have carbon capture uses in storage as an option, which could be also valorization of CO2. So there are a lot of options which are not really integrated, and we like to discuss on this topic here. I'd like to introduce our round. So in Germany, they couldn't make it, is Professor Dietmar Auer, who will give our first lecture. He's director of the Max Planck Institute for Innovation Munich. We have then also on the internet, Dr. Carsten Lambertus, who is the managing director of DEEP, a deep tech innovation a center at the European Management School of Technology in Berlin. And here in our round, I'm very happy that Anja Muschner is here. She's from the background, she comes from the art of history and history of arts, but has worked for more than 20 years now on transformation and how transformation paths can be totally accepted. So I'm very happy that you're here, Mrs. Muschner. And then I'm very happy that my friends from China are here, Professor Jiang. Professor Jiang is professor at the UIB, University of International Business and Economics in Beijing, one of the most important 211 universities in economics in China. And he is also head of the zero carbon emissions Humboldt Forum, which is a German-Chinese project, and annually in Beijing, where he is the head of this conference. And this is also collaborative done between Germany and China. So I'm very happy that Professor Jiang is here. Professor Fong is the secretary of this conference and a long-standing friend of Germany. He speaks fluently German, by the way, and is former Humboldt awardee, CEO Humboldt awardee of the Humboldt Association, and helps a little bit that the things go smoothly here. So this was a little introduction. So first of all, I also like to introduce Andreas Löschl. We haven't got very good sound, but in the preparation, we spoke with Andreas Löschl. Professor Löschl is a professor at the University of Bochum in Germany. He's member of the IPCC board, so he's IPCC author. He is also advisor to the German government, and we will have a little introduction. He will be here next week, so he will give us a little short notice. It will be a little bit, so we have to be very quiet now. So here, because some problems with the sound, probably he was ill when he took the video, or we are a little bit not the technology available. Please, Christian.
Greetings to Baku. It's an honor and a pleasure to send regards to this very important conference on sustainable and just transitions, innovations for a greener tomorrow. We've chosen an important topic that is, well, decisive for the energy transition. In the IPCC report, we looked at the role of innovations for the future energy system, for the climate neutral energy system. And it's clear that these energy systems, they share some common characteristics. And in all these characteristics, innovations are necessary to achieve emission reductions. The energy systems of the future are going to be characterized by large-scale electrification of energy uses, but there are also necessity for alternative energy carriers, such as hydrogen, bioenergy, ammonia, to substitute fossil fuels in sectors that cannot be electrified. We have to be much more efficient than we are today, and we have to use CO2 removals, direct capture, carbon capture and storage, bioenergy with carbon capture and ACS and X technologies to offset residual emissions and to move to a net zero world in the future. All these technologies that are needed for reforming or for transforming our energy systems are at the moment not on the market. They are not competitive, and they are very far away from being available in large quantities. So we need innovations. We have to bring down costs. We have to find solutions that are not there at the moment. So therefore, I can only congratulate you on the topic of your workshop, and I'm very much looking forward to seeing the results of your methodological discussions. And of course, I'm also very much looking forward to discuss in person with you probably next week when I'm in Baku or in coming time what you have discussed and the solutions that you are proposing. Thanks a lot. Greetings from Germany.
Yeah, this was a video as motivation for our discussion. We all know negative shocks like Corona, which affected very strongly our economy. Disruptive innovations could be described, as Andreas Löschel more or less said, as positive shocks. But to really describe this and integrate this into models, obviously, this is very ambitious and has not been done methodology. And this is our point today. We want to speak about methods, how we could integrate disruptions into our scenarios and into our models. And therefore, I'm very happy that Professor Haupt is here. And perhaps we can just start now with your presentation, Professor Haupt. Could you say, you can hear me?
Yes, I can hear you.
Yeah, very good. So the floor is yours. I already introduced you. We're very interested about your vision on disruption for our energy and climate transition.
Thank you so much. Thank you for having me. So my daytime job is to think about innovation, and that also includes thinking about the statistical properties of innovation. So I'm trying to give you an economic statistical appraisal of breakthrough innovations, sometimes also called radical innovation, leapfrogging innovation. There are many names for this. I want to talk about two aspects. One is how can we sort of statistically capture what these type innovations do? And the second one is, are there also ways of systematically promoting the likelihood of these innovations coming out? And that will be firmly in Thorsten Lambertus's ballpark. But I want to report briefly about a German effort to bring about more radical innovation that helps to reach to resolve the challenges that we're facing right now. Next slide, please. Okay, so I don't want to give you a technical definition, and by the way, there are many views as to what constitutes a breakthrough innovation, but typically these innovations address long-standing, very tough problems for which we haven't found a solution for a long time. They are typically very rare. We don't have them in the newspapers every day. They are events that come maybe once in 5 or 10 years. But they have massive implications for productivity, for market structure, and of course also for contributing to the technical solutions to decarbonization and the energy transition. They typically receive massive attention. So what we see when a patent that is behind such an innovation comes up, that it garners almost instant attention and then citations and so forth. So we can measure this by looking at the attention that it gets in the technical community, in the economics community. And as I mentioned, there are other terminologies out there for this, radical and disruptive innovation. There are subtle differences. I don't want to get into those. So the questions for the panel were today is, how should we account for these in climate models? because currently technical progress is essentially a constant and not contingent on innovation efforts in these models. So the attempt is, that will be very much in Andreas Löschel's ballpark, to sort of build that in order to have better predictive tools. And that leads me to the statistical properties that are important when contemplating endogenous breakthrough innovation. Next slide, please. So the next slide, I'm trying to give you in a sort of playful mode an intro into the most salient statistic or characteristic that these innovations have. And that characteristic is called skewness. Typically, when we work statistically, when we model, when we simulate, we are always tend to work with normal distributions and so forth. The normal distribution is the central tenet of what we do when we do financial modeling. Well, if you look at the microstructure of radical innovations, you find that there is skewness, meaning that very, very few events carry the lion's share of the impact or of the value. So in order to show you that, let's look at some data from a somewhat aged study from 2000, where we, a team consisting of Frederick Scherer, myself, and Jörg Cookies, who at that point was still a doctoral student in finance, but was working on the topic, where we look at the value distribution in patents, where we find that the top 10% of patents in a random portfolio carry 90% of the value. So this is a very, very, how shall I say, unpleasant property, because it makes diversification very, very difficult. You need really large samples in order to hit a few of these very, very valuable inventions or radical innovations. And I've tried to capture that in the picture. That just imagine that you're colorblind and you cannot see whether the little Bärchen, the sweets are red or green, and you have all of them, and you need to taste all of them or a sequence of them to figure out which one is the green one, the sweet one, while the others taste very bitter, meaning that they are financial disappointments. And of course, there's literature on this, and one of the most telling political statements is from Mao Zedong, who said, "Let 100 flowers bloom." We need a lot of attempts, experiments, in order to come to one good one that carries the day. Next slide, please. So this has been analyzed in simulations. And what comes out in these simulations, here is one example, Frederick M. Scherer, who was in my very influential for me. He conducted around 2,000 a number of simulations. He concluded that we can likely describe the statistical properties of inventions by a Pareto or log normal distribution. Now, the Pareto has a few very unpleasant properties under certain circumstances. For example, that is a distribution that may not have a stable mean value. The mean increases as you sample more and more under certain conditions, whereas a log normal has relatively manageable properties and could be built into these models. And that is my suggestion for doing this. Next slide, please. That opens, of course, the question as to, well, how do we get at this? How do we do this? How do we sort of create favorable boundary conditions for having these wonderful innovations with massive implications, which will make our way towards energy transition and to decarbonization easier? And there are a number of models out there, and one that many of you may know is DARPA, a US model, the defense agency, that has tried to bring out innovation, radical innovation for the purpose of defense. And recently, governments in Europe have become very interested in setting up agencies that pursue radical innovation, and one is the German Agency for Disruptive Innovation. And I want to tell you briefly one aspect of what it does, because it sort of embodies many of the features that I just talked about abstractly. Next slide, please. So, agencies that support innovation typically have access to a number of tools. So does this agency. I don't want to go into all of them, but what is very, very interesting here is that this agency runs challenges. So it sets topics and then invites people to come and to sort of be in a tournament and propose solutions, work on the solutions, and it finances the search for these solutions. Next slide, please. Let me give you an overview of what these challenges entail. So this is a timeline and a list of challenges that have been organized by Sprint, the agency. And I've signified one here that is the carbon to value challenge. That was one where the agency said, hey, inventors, please come, describe to us approaches to turn carbon, as in CO2, into something that is valuable so that we can sort of build commercial incentives for decarbonization and facilitate our task, energy transition. And essentially what they do is they select a number, a relatively small number compared to the applicants. So there might be 40 applicants, 10 are chosen to enter the tournament. Each team may get anywhere between 1 million and 2 million euros support. And after 1 year, there's another selection step that tries to tease out, okay, what are the most promising concepts? Then you narrow the number of people who get further support, but you hike up the support. So it's an inverse funnel. If you want, the number gets smaller, the amount of funding gets larger. And this is by now a recognized way of, for a particular topic, for a field, in this case, carbon value. But if you look at the other ones, also for long duration energy storage, another topic that is relevant for the energy transition, to get to radical innovation. Next slide, please. Next slide, please. Okay, and what I'm trying to, let's go directly because to save time. Let me give some final comments and then pass it back to Ralf Esborn. As I told you, there are political difficulties associated with this mechanism. One is there's a high failure rate. That is not the logic that is easy to explain to our political stakeholders, right? It's not for the faint-hearted, because typically controller generals, Rechnungshöfe, look for success rates. So if you tell them that the failure rate is 80%, they might get nervous. What you need to run these agencies is very much a people-centered approach. You need to have people who are familiar with the innovation process, people who are expert on the technical domain, on the field, and you need to select them and then trust them. So this is not necessarily a job description of the standard bureaucrat. It's also a difficult communication task to the public because you have to tell them what happens to their tax money. And if you, again, come back and say 80% of the projects failed, that might be difficult to communicate. So there is a kind of tyranny of small numbers. There are many experiments that are needed to find candidates for radical innovation. As I told you, that tyranny can only be broken by having many experiments. That means we have to have international collaboration. That means that the many agencies that are springing up now, ARIA in the UK, Sprint in Germany, the EIC at the European level, have to collaborate on this difficult task. Thank you for your attention.
Yeah. Thank you very much, Professor Haupt, for your statement, also your position that essentially with some statistics like a log-normal distribution, I'm happy that you took a log-normal distribution, not a Lilly distribution, which is the earthquake distribution. So this can be normalized. This could be a way to integrate in scenarios. Thank you very much. Our next speaker is Anja Mutschner, and she will have a look on this point as Professor Haupt mentioned at last one. Why is the acceptance of this disruption so low? And I'm very happy that you will now be our second presentation. Mutschner is here. Yeah, please.
Hello, good morning. Mr. Ambassador, esteemed audience, and special thanks to Ralf Esborn for inviting me on this panel about radical innovation for a greener tomorrow. And I keep honored to be part of this session at COP29, especially at such a crucial moment for climate research and action. The urgency of climate crisis and the ongoing struggle to find a global solution seem irresponsible at times. However, the good news is that after moving beyond the debate of one size fits all, okay, I can talk like this, it's really better. Okay. Okay, better? Yes. We have, sorry. The good news is that after moving beyond the debate about all climate actions, we have the opportunity to start fresh. And social science offers promising approaches that can turn radical innovation into sustainable radical innovation, reconciling two seemingly opposite forces, the need for disruption and the desire for continuity. My short presentation today is based on over 15 years of experience as an founder of a transdisciplinary innovation think tank called Quick Move and recent research at the Kairos Institute at Hochschule focusing on innovation in underprivileged regions. Key question I like to explore is how can we bring the input to the ground, meaning radical innovation. How can we land it in left behind regions? And what lessons can we draw from this for the broader innovation discussion? So please, next slide. Let me start by addressing the concept of radical innovation from social science lens. Radical innovation, as defined by Joseph Schumpeter's theory of creative destruction, involves a discontinuity from the current state of the art. It disrupts, like world industries and systems, replacing outdated models with more efficient and advanced ones. This theory still forms the foundation for most disruptive innovation strategies and master plans that rely on triple-down effects. Next slide, please. However, in today's context, particularly when addressing climate change, radical innovation must go beyond technology alone. It must also address social systems. And the crucial question is, how do we achieve this? Through shocks or holistically? Here I show you an abstract painting to illustrate this idea, and I will explain soon why I choose this image. Yes, now next slide, please. As Morrison in 2022 argues, radical interventions with sustainability must address the root causes of climate change through structurally transformative pathways. His redefinition of radical innovation comes with a strong premise, questioning capitalism at all. So this is the most radical answer from social science you can find. The core idea is not necessarily wrong though, and it can be found in many other studies and theories like Howard and Schwartz, because it is clear that sustainable radical innovation can no longer be seen as purely technological. It must be systemic, involving shifts in governance, behavior, and society practices. But why is this approach so critical for successful innovation? This becomes particularly evident in underprivileged regions where social structures may be fragile or fragmented. Next slide, please. As Paul Collier this year highlighted in his work on left behind communities, these regions can catch up through collective learning, moral leadership, and local empowerment. But this requires aligning the interests of diverse stakeholders, governments, businesses, local communities, around the shared vision for sustainable development. Next slide, please. One key concept that may help us understand how to drive radical innovation is what Helen Latour and Eckridge call art of investment. And as you can see, I sign art and investment because that's the most interesting thing about it. Innovation is then not a solitary endeavor, it constantly seeks allies, and to succeed, it must embed itself within a network of actors who adopt, support, and disseminate it. In essence, we need to think about innovation as an art form, one that creatively brings together different actors with different goals, which is, in the end, art. It's not always linear or predictable. In fact, it's often messy and ambiguous, but this is where the power lies. And allow me another remark about its fuzziness in these traits. Because fuzziness is great in innovation. It's not a weakness. The early stages of radical innovations are often characterized by uncertainty and ambiguity, and this fuzzy front end is where new ideas are more tested and adopted, like we've heard. In my experience working with innovation systems, especially in underprivileged regions or complex stakeholder environments, I've learned that accepting this fuzziness is key to success. Not everything will make sense right away. Not every idea will work out as planned, but that's okay. What matters is being open to change and willing to adopt based on feedback from stakeholders. And at an event like COP29, we see this fuzziness in action. Different countries, organizations, and communities come together with different approaches to solving the climate crisis. And while there might be disagreement or competing interests, this diversity is exactly what makes progress possible. Next slide, please. But how can we keep up a pace and produce something like positive shocks? And I took an emotion actually here, because I think hope can be a catalyst for action. It's a concept that is often overlooked in discussion about innovation, but it is crucial for driving action. And if you read on sustainable activism, you can read a lot about hope. We couldn't spend an hour actually analyzing hope. It's both mindset and the tool set for climate action. For now, let's view hope as a catalyst and positive shock society needs to move on. As Evan Morrison points out, book can serve as a catalyst by inspiring people to believe that a better future is possible. And I think people who look here, people who sit there, are in urgent need of some hope in these times. So maybe this kind of discussion can bring us the very, very effect of hope. In the context of climate change, hope plays an essential role in uniting people around ambitious goals, like achieving net zero emissions or building resilient communities in underprivileged regions. And create what Ernst Ayers blocked, can't block it, called realtopy, concrete utopias that inspire us to take action towards systemic change. Hope doesn't mean ignoring the challenges we face. Rather, it means believing that we have the power to overcome them through collective effort. Next slide, please. So I come to my conclusion to redefine and think about how we can bring the info to the ground. So if we are serious about driving radical innovation for sustainability, we need to redefine what progress looks like. This is a question I like to discuss later on, because especially in underprivileged regions, this needs to be a very important thing. It means embracing both technology advancements and social innovations that empower local communities to take control of their own futures. So sustainable radical innovation is always sustainable. It also means accepting fuzziness as part of the process. Be open to change in our minds when new information or perspectives arise, and fostering hope is a catalyst for collective action. And we can think as Germans, as we believe that there is still room to learn this kind of embracing fuzziness, because to have a disruptive mindset is something and we might have to learn. I'm convinced that this approach, one that integrated technology with social systems and embraces uncertainty, is key to achieving sustainable radical innovation. So thank you. I look forward to our discussion and your thoughts.
Yeah, thank you very much, Frau Mutschler, to bring into context the different stakeholder perspectives and also reframing positive shocks, because nobody can understand what possible shocks are as with hope. So we have to discuss this. It's in the direction of this philosophy to make really disruption measurable. So I'm very happy to hear now a little bit the view of China. So we're very happy here. We heard already from Professor Haupt that carbon to value is a big topic, and Professor Jiang is working since a lot of years in the area of carbon economy and is pushing now zero carbon economy in China as leader of a big conference, annual conference towards zero emission. And so we're very happy to present. Jiang will speak in English slowly, and we will have discussion later a bit different. Please.
Okay.
Perhaps we need those.
Money is Amtiat. University of the National Business and Innovation my purpose established an entry and part of historical and structured real taboo parts chance practice. Our goals for fire, carbon parts, how we are building the day and what lies ahead. Part 1. Why build zero parks? Firstly, it's essential for China's climate strategy. Developing zero carbon park allow us to create the credible, replicable models for zero carbon zones at cost or its prices that drive regional carbon reduction. This supports China's carbon peaking and carbon neutrality goals and contributes to global limit boundaries. Secondly, it's a practical starting point. The carbon neutrality involves single emission action technologies for integrated approach and individually systematic damage. This progression involves aligning united destruction, pollution control, ecosystem protection, and climate response. It's about reducing carbon and pollution, expanding green area, and prioritizing sustainable growth from the coordinated policy action in various public fields. Thirdly, zero carbon parks are also in a transition carbon tariff. The EU's Green Deal, SEPA, US policy like Inflation Reduction Act, all has climate issues, trade, and industry voice. For China, zero carbon parks are a crucial response to these developments. Finally, industry parks are a major emission source, as which the global manufacturing are about 30% of China's total emission come from industrial parks. The zero carbon park model is emerging a new approach to meet the strict decarbonization goals. At goal, all of China is using zero carbon parks. Developing zero carbon park is a dynamic process from low carbon to near zero carbon and ultimately to net zero carbon goals. Since the beginning of 21st century, China has established approximately 95 eco-industrial demonstration parks, 180 survey economic demonstration parks, 51 low-carbon industrial parks, and 267 green parks. These efforts have laid a solid foundation for the emergence of zero carbon parks. Since 2023, more than clean provinces in China, about 1/3 of all provinces have issued policy documents related to zero carbon parks. Building zero carbon parks is a complex endeavor. Carbon neutrality must be integrated throughout office planning, construction, and management. Achieving these studies requires energy saving, emission emission reduction, carbon capture, and resources recycling. These areas include low carbon intensity practices, green energy transition, shared infrastructure, smart carbon management, and circular resource use. With policy support, you will successful exam of zero carbon paths have emerged achieve your PPT. Touch free. Europe directive for zero carbon paths. First, strictly top-level design. You pass in part of this line national and regional policies and explore aviation zero carbon bonus, such as tax-focused zero carbon zones, or you national education in liquid parts. Establish an international zero carbon path alliance to share experiences. So, books focused on zero carbon products. Run our time, zero carbon raw materials, intermediates, and products to stretch quality in global qualities and overcome carbon curve. Suppose innovation, enhance workforce speed, and improve habiting and monitoring. Third, expanding financial channels, set up zero carbon fund, development fund, and provide real financial options such as real loss and credit tax, especially for small business, encourage public partnership and financial innovation. Four, standardize evaluation criteria. Develop comprehensive studies for zero carbon paths, including carbon capture technologies, ecosystem usability, and a certification system. Finally, accelerate the clean energy option, utilize bridging smart energy supply network that supports precise and efficient energy use, embraces renewable energy development, and promotes advanced clean energy technologies. Thank you. Thank you.
Thank you. Thank you very much, Professor Jagatni. Let me put this in the framework with the discussion on. Your thesis is to really achieve the transition, we need the zero industrial carbon parks. So it's a governance-centric approach. Having these zero carbon parks, we are on the track, and these would trigger innovations within these parks. Yeah. So it's very interesting to see your approach to this disruptive going via governance-oriented structures. We will now have on our last presentation by Thorsten Lambertus, just the opposite view, not governance-centric, but humanocentric. So how can we bring people to be really disruptive? And I'm very happy to see now with Dr. Thorsten Lambertus, who is a managing director of DEEP in Berlin, that he will bring us some insight on the topic, how he achieves disruptive innovation. Please, Mr. Lambertus.
Thank you very much for having me. Hello, everyone from Berlin. So my perspective, I'm not an economist by training and by background, but I've been supporting people to create radical innovation now for over 15 years. And so I want to give you that practitioner point of view and perspective on how we can facilitate radical innovation to achieve energy transition, all the transformation, the green transformation that is highly needed. But to get started, let me take you back to a time where humans, in order to get from A to B, They either had to use their legs and their feet by walking, or they were using a horse. And then there was crazy people coming up with an engine, a combustion engine, and building a car around it. And suddenly an innovation happened. And there's a beautiful quote from that time, which goes, "Global demand for motor vehicles will not exceed 1 million, simply for a lack of available chauffeurs." 1895 by Gottlieb Daimler. And it tells me how difficult it always is, even for experts, to predict how new inventions can radically change the world and can change the way how we interact with the world. It's something we've never met Gottlieb Daimler. We have probably never met the people who at that time were taking the first cars and actually using them, driving them on those streets that were not streets, that were paths for horses. They got stuck in muddy roads. They got stuck, and the tires broke. There was no infrastructure for gas and even to fuel those cars. And there were many people making fun of those people driving those cars. But they weren't making fun of that for a long time, because as we all know, this became a global innovation that helped us to change actually how mobility works and to change the world. And it's a nice example of how hard it is to predict that certain technologies come to life, are being scaled and change our lives. And it also tells us that we need, of course, a lot of infrastructure changes sometimes so that these innovation can actually be useful. But in the very beginning, they look a bit awkward and they look a bit strange. And so no one is believing into that. And I guess now that from the practitioner's point of view, maybe also the problem with the models, that it's so hard to extrapolate from the past and to see what we would think of is doable and is feasible, and then we get surprised. And I think we got surprised by scientists so often when we have certain examples like the telephone, the light bulb, statins is a nice one, CRISPR gene editing, even what we now see in AI and quantum. This was not a continuous development of R&D and new technologies, but this is why it's called a breakthrough technologies. There's certain challenges that people want to overcome, and at some point there's just the breakthrough, and quite often it's not just one person managing to get to this breakthrough, but it's simultaneously multiple researchers, inventors, and entrepreneurs working on the same challenge, and then suddenly we have a new innovation that is surprising everyone out there. And this is what we should bet on, that we can create, and that science and entrepreneurs will create those surprises also in the future. And if we look at all the big pictures when it comes to green transition, really exciting technologies, green hydrogen, direct air capture. When we look at the energy problem, fusion energy, the small nuclear reactors that are currently being developed and even bought by large corporates that want to make sure that the way how they generate energy and how they power their activities and their businesses are done in a more sustainable way. Bioreactors for material production, plastic degrading enzymes. These are all beautiful examples of new technologies, breakthrough science that is happening. And that's when we compare to the telephone, or when we compare it to the car, what is still lacking is the scale and the commercial scale of those innovations. So actually bring the business part and the entrepreneurial part to the science and to the research. And that's exactly my role at a leading business school in Germany, the European School for Management and Technology, that we support facilitating the transition from an invention to an innovation by adding the business and the entrepreneurial side to the research and the science. And so what I would like to just to touch upon in my short impulse is to highlight 5 layers of support that we need to think of if we want to facilitate radical innovation. The first one, I've been working with large research organizations for quite some time. It's always surprising and be astonishing to see what new technologies all those smart minds are working on. But sometimes, and not only sometimes, quite often, these invention and these technological developments, they get stuck inside research and the research organizations. And how do we think about mobilizing that potential of new innovations that help us with the transition. First of all, we need to make as many researchers as possible aware of how can you think about the commercial application and thereby scaling your solution to the world by educating them on entrepreneurship, by making sure they get the confidence also to not only being an excellent researcher, but maybe they can also transition to become an excellent business person and an entrepreneur, creating an innovation and scaling it globally. Second, we need to work on the mobilization of tech transfer or tech translation by supporting research organizations to create an interface between the research world and the business and entrepreneurial world by standardized, easy to use agreements between the universities and the business side. How do the business people make use of technologies? What are the conditions and the processes that help entrepreneurs to get access to new technologies? Because what I can see in the startup ecosystems, not only in Germany, not only in Europe, but around the world, but there's lots of entrepreneurs, and over the past 2 decades, have maybe gained a lot of experience in how to build a business, and even gained a lot of resources, which means basically money and network, by building tech businesses, by building software businesses, by building online marketplaces. And now they are very motivated to create companies that help us to tackle big challenges around the green transition. But they do not have the capabilities to build a nuclear reactor. They do not have the capabilities to use industrial biotech solutions to turn waste streams into new materials. And this is where this interface comes into play, where we need to make sure that entrepreneurs who are experienced and willing to create businesses, that they get access to new technologies. And there's a lot of different ways how that can be done. Just to take an example, for example, from the life sciences, when I look at an entity like Flagship Pioneering in Boston, that is A, an applied research organization, but B, also an entity that creates companies from scratch in a very systematic way, and then C is also able to scale them to companies that we all might know due to the pandemic, like Moderna. That's a company with breakthrough technology that emerged from such a company building entity, and that was bridging the world of science and breakthrough science and the entrepreneurial side of building and scaling a business. And so this brings me to that second layer, mobilizing the potential of the research by educating researchers and making sure we have that interface ready to do tech transfer right. Second, to make sure that entrepreneurs get access to new technologies and can build business out of that, because they have the appetite, they have the motivation and the capabilities to scale innovations globally. And this is also when Dietmar Hauf talked about Sprint, which is a wonderful model. It really works. It's still a young organization, but we have been working with them in their Circular Biomanufacturing Challenge. You saw that on the slide as well, where they selected breakthrough science from all over Europe. And they gave them very ambitious targets where no one was really thinking like they can achieve that. But giving that freedom and that money and that support by Sprint to those teams, they were able to achieve results that no one would have believed they could. And we were coming from the business side and kind of create a mentorship environment, a high pressure, but also high support environment where experienced entrepreneurs, venture capitalists, corporate decision makers, and also scientists had those young breakthrough innovations to understand what is their market and how can they build a business around that technology. And if I'm thinking about, for example, Quantum Leap, that produces biologically generated platform chemicals for the 3D printing industry, they came as a pure team of researchers. And we turned them into confident entrepreneurs. And we turned them into having a clear vision of that, how that can become a thriving business. And these are the examples where, if we look at the portfolio of inventions out there, we add more of the entrepreneurs to those technologies so that they can make use of it. And we have a support system that helps those young companies to position themselves right in the markets by using the experience of people who have done it before. Then we are on the path to radical innovation. A third layer is many of those startups innovations struggle to build their first prototype, to build their first business, have the first customer. We know from, for example, how the US works, but many other examples, that the government could play a big role of becoming a first customer. But also major corporates that have technologies, that have facilities, that have lab space. Just yesterday, I talked about quantum computing and how all those new computing concepts, they need access to very special measurement facilities to showcase their potential. And the same is true for someone building a bioreactor to support with the industrial transformation. We can talk about life science companies that need access to infrastructure and lab space. We need to make sure that we provide that space and that experimental ground for new innovations to happen. And quite often we are not open enough and there's not sufficient support when it comes to that. Let me come to the fourth layer, and that is acceleration and making sure we support startups in scaling the business. We touched upon in one of the presentations today on creative destruction, the Schumpetersche concept of making sure we have radical innovation, how they happen. We are running the so-called Creative Destruction Lab. It was one of the first startup accelerator in quantum computing worldwide 7-8 years ago when this has been launched. And so we take the liberty in many different places in the world, but also in Berlin, where we invite innovators, startups that are about to scale innovations globally to get access to such a rich ecosystem of mentorship so that they do their business side right and that they become the business and entrepreneurial support they need to scale. So this is something where all those companies run into that challenge. How do I build an organization that is ready to scale? How do I build a business? How do I build a business model that makes it sustainable to scale from a business perspective? And that's a support scheme we need to make sure also for all those science-based companies and the key technologies we're talking about for the green transformation, that this is ready. And then the final and fifth layer is having access to the right capital, to venture capital that is taking the risk. And we could talk about here how the startup ecosystem thinks about that power law, that power distribution that also Dietmar Hahoff was touching upon, and make sure we have a lot of bets, a lot of different investors investing into new breakthrough technologies, because we never know which of the companies and which of those technologies will succeed. So we need many bets, and we need that money that is taking the risk and that is also helping with the big and sometimes huge amount of money that is needed to not only build a first prototype, but also to build the capex, to build the facilities, to build infrastructure and supply chains that will then finally build the businesses and the companies that provide solutions to all of us that help with the green transition. So these 5 layers is where I feel we need to do even more to make sure that science is being turned into business and then can be scaled. And if we do that on scale all together globally, then we'll see things that will really surprise us and change the world and disrupt the world in a very positive sense. So thank you, and I hope that impulse is what you were looking for, Professor Wesch.
That's that. Yeah, thank you very much, Mr. Lambertos. For sure, that's really what is needed in doing. So summarizing this, the presentation is, I think we have all the ingredients, actually, with all the ingredients to bring disruption into a scenario of climate change, which is not included currently. And so my last round, we have, I'd like to make a last round to ask everybody, how can we have shown we have models, we have institutions, we have zero carbon park, we have governance structures promoting disruption in the energy. We heard CRISPR-Cas, we heard the light bulb, all disruptive innovation, but they were not planned. They were just somehow coming inside. So but we spoke about planning disruption in the sense that Mr. Hahoff explained, we put a normal distribution to bring this, and then we put a positive shocks in the economic models. So this is all possible, and I have the feeling if one brings everything together, one could really put in some more confidence in disruption, also in climate models, but it's not done yet. So what is your opinion, or what would you say as part of say what is needed to convince more people of the potential of disruptive innovation? I'd like to start with Professor Hahoff. What is your wish here on the conference here to have more confidence on disruptive innovation? Perhaps you can start and then we go around to everybody.
Yeah, thank you for that question. I think what comes out of a simple analytics description and this term, the tyranny of small numbers, the tyranny of small numbers is not supportive of what Anja Muschler mentioned, hope. We need to get up the rate of experimentation, the number of experiments. Many of these will fail, but I think as a community we'll be carried through by a sense of hope and optimism that we can provide solutions and that we can find approaches that will help us in this daunting challenge of getting to energy transition and decarbonization. So my wish or my recommendation would be hike up the rate of experimentation. We do this in Europe now in the European Innovation Council. We give more money to these activities. We try more systematically, as Thorsten Lambertus has described, to do these experiments. And I'm convinced that that will help us to find new solutions of a radical kind.
Yeah, thank you very much. As a Muschler?
Yeah,
Oh, you got it. Well, okay, yeah.
right.
Yeah, this-
So, and I take this my. Yeah, it was very inspiring to hear all your wishes that I think complement an image of what a radical, sustainable, radical innovation can bring to us. And then for me, it is really to accept the fuzziness in the beginning of the process, both from the science side, where we see it's not obtainable, we cannot manage everything, you need to have the method, and this is why it's also for society, right? You need to integrate the heterogeneous, the reluctant moment of something you definitely, I don't know what will happen, and then with strong leadership. You need community-based organizations who can tell story until the next step is done, and you can see first results of how it's being innovated, because you had always this moment where we as scientists can see something, but the public at, and that's usually the moment where you can fail, and if this time lapse is too long, people might forget about the vision that is behind radical innovation, which is a good water. So we need to bridge this gap, and this can be done through stories and through combined effort and a realistic one as well. So for me, when I at up here, I see so many good interventions that we could talk about, and sometimes we hinder us to go out and look openly because we have some ethical or moralic reluctance inside us, and then we need to reconsider our stories. I mean, what you told us was very exciting to hear. There are solutions we can do, and we can go big steps. So somehow, for me, it is to retell also the story of sustainability, and then we can restart again our corporate English speaking.
Nee, meine Frage, ja. Wir sind ja multilingual, ich mal auf Deutsch. Meine Frage jetzt an Professor Jiang ist, er hat ja über den Zero Carbon Park gesprochen. Und die Frage ist, wie kommen dort disruptive Innovationen in diesem Konzept, wo kommen da disruptive Innovationen vor und wie ist die chinesische Meinung zu disruptiven Innovationen? Disruptiv heißt radikal, was ganz Neues. Das übersetzt.
Würde du
Er kann ja Chinesisch sprechen und dann übersetzt.
Give a point at press process as in Chinese.
Definition 啊，它是一个 slash。那么在这里呢，我自己关键要素，一个是这个
能源的去的化。
the zero carbon park ist ein komplexes System und da gibt es ein paar elementare Parameter. Der erste ist Columbus Energieversorger, dementsprechend innoviert.
企业的地产方案，
Industrie da, die diese Hauptaufführung der JKO ist ja
包括整个这个能源管理智能化。
es gibt man auch AI einsetzen, um die Semikonduktore zu optimieren.
所有这一项都需要技术创新。
Und für all diese Teilsysteme muss man technische Innovation einführen.
但是在我们研究过程中也发现呢，仅有技术创新还不够。
Unseren Versuchen habt ihr entdeckt, dass es sich auch nicht nur auf technische Innovationen begrenzt.
我们每天看到都有趋势创新，这些创新呢，往往是单一创新。
Also ich bin so jeden Tag eine neue technische Innovation, aber auf sich selbst begrenzt.
单一创新呢，它能够起到一些好效，但往往在业务过程间呢，抗风险能力比较弱。
Das führt aber in der Praxis dazu, dass man gegen Risiken relativ schlecht absichert.
所以我们有需要发展的技术基础创新。
Wir würden darauf kommen, dass wir die urbanisierte und basierte technische Innovation einführen.
那么放到一个气候治理的角度来说，它是一个非常大的空间。那么我们要想做好这个事情呢，因为我们往往从一些具体的领域来说，比如说一个园区、一个区，如果能够把气候这个事情起来，我们可以创造一些更多的收入和对往更大方面的支持。
Also wir wollten da eher auf der Ebene zum Beispiel auf geeigneten Zero Carbon Parks ausgehen, dass es systematisch herangehen und wir dann wichtig den Beitrag zu der Kontrolle der Erwerb leisten.
在一个区域里面要做好，我们就需要区域的协同创新。
Also in diesem Park muss man auf der besten Ebene, auf der Top-Ebene, alle die Stakeholders, glaube ich, optimieren.
因为在区域里面，它可以协调更多的有效因素，从而能够做到节约是 profit， 就是能够把资源利用。
Also das müssen wir von der Grado her schon Optimierung der Energieversorgung mit allen anderen Systemen abgeben.
但是最终要实现碳中和这个目标，我们需要走到新资本方式、新领域。
Also das Ziel der nur Zero Carbon Park zu erreichen, müssen wir es systematisch aufeinander bei der Planung, bei der Bau und
这里面是一起做。
was you was in haben bis am Anfang sind wir ist dran.
Okay. Sure. Okay, thank you very much. That's interesting to have an infrastructure approach for innovations and particularly also disruptive. Thank you for your view. And then, Herr Labertus, perhaps you can add on this point. What is your opinion? Why essentially disruption or how we can promote disruption in the scenarios of the IPCC. I mean, you're working day and night with your teams to bring really disruptive innovation to life. What is your wish? What is your recommendation here that we have more confidence on what you are doing towards our climate transformation?
Yeah, thank you. I guess we should bet and we should believe into research and entrepreneurs, and in that combination that they will do their job. And all we need to do is to create fertile ground. And fertile ground means they have the liberty to work on different experiments, find different approaches of tackling the challenges. We need to make sure that they just find the infrastructure, the support structure, the funding they need in order to create all these experiments. And then we'll see how they will radically change the world. But only by doing that on scale, jointly between science and business, we will see those results and thereby also get the solutions that are highly needed. And then whoever is trying to predict how the future will look like with whatever model will also probably be surprised on what is the outcome.
Okay, thank you very much. And then thank you very much all to our speakers. We have been live streamed to put all this together with Robert Pater. Thank you very much. I found this very interesting. I thought we had a lot of insights from the different perspectives. I like to write this down so that we have really an outcome of our session, and then we will distribute this. So thank you very much for this first session. I'd now like to pass the moderator role. So we are finished. So I pass the moderator role to my colleague, Professor Evers, who will share now the second session. Thank you very much.